Today we're going to talk about how we would measure strength. Judging the strength of a relationship when you see it in a scatter plot is difficult to do. One person might say there's a weak association, others might say there is no association. Fortunately, there's a numerical way to measure the strength of an association, and that is the correlation. So correlation is a measure of the strength of a linear association between two numerical variables. Okay? So again, you can only find the correlation when we're graphing two numerical variables. Categorical variables, it's out. And correlation is often referred to by a lowercase r. So when we talk about r, we are talking about the correlation. So let's talk about some properties of the correlation. The value of r always falls between -1 and 1. Secondly, if the association is negative, then that means that your correlation will be negative, less than 0. And if the association is positive, then your correlation will be greater than 0. Let's say that the data is exactly on a line. Then that means that r is equal to 1 if it's positive, or if it's a perfect negative association, it's equal to -1. If there is very little scatter, which means that we have a strong association, then r is going to be close to 1 or -1. Remember, 1 or -1 were perfect association. So if it has a little scatter, it'll be close to 1 or -1. But if there is lots of scatter, then it's going to be closer to 0, and that indicates a weak association. One nice thing about r is that it has no units, and it is not dependent on the units used to measure the variables. So again, it makes it an ideal way to compare strengths of associations between different sets of variables. Another interesting feature about r is that the value of r will not change if the variables on the x and y axis are reversed. So again, the value of r will not change if you switch the x and y variables. We do have to remember that the value of r only measures how closely the data falls to a line. If there's a curved pattern, using r to measure strength would not be appropriate. So here's what we could do. Well, first let's kind of talk about r, like the value of r that we can have. I kind of have this number line here to talk about the different values of r. And we're going to first look at when r could be weak. So r could be weak anywhere from when the absolute value of r is between 0 and 0.5. Now, I know a lot of us are weak with absolute value. So really what that means is that if you went from -0.5 to 0.5, these would be the values of r that would be considered weak. Okay? So these are the values, again, of r that are considered to be weak values. Anything from -0.5 to 0.5 is considered weak. A moderate association would be anything from -0.8 to -0.5, or from +0.5 to +0.8, okay? That's going to be, I'll put just a little m here for moderate association. And then a strong association would be anything from 0.8 to 1. That would be a strong association. I'll put a little s for strong. So that's how I think even in AP they define the strength of association here by these absolute values. I thought this continuum might be a little more helpful to you guys. Okay. So let's use technology to calculate our R value. One kind of annoying thing is that the Texas Instruments people did not default this feature on the calculator. So to do that, we have to turn the diagnostic feature on. So what you're going to do is you're going to hit the second key and then the 0 key. Remember, the second key is at the top left, and then 0's down here. And when you do that, you end up with this catalog. Then you're going to scroll to diagnostic on. So you're going to go ahead and scroll to diagnostic on. So you see diagnostic off, which is not on, and diagnostic on. You're going to arrow to where it says diagnostic on. Oh, let's read directions. And you press enter, not once, but twice. We hit enter and enter again, so it says done. So now it should say diagnostic on, done. Now the calculator will give us the R feature that we're requested, that we want it to. If we have not done this, it will not give us the R value. So if you're like, why isn't R showing up? It's because you didn't follow this instruction. Okay? So here's how you can find, so now that we have that, we can enter the data into L1 and L2 in the calculator. Remember how to get to L1 and L2? If not, shame on you. You go to Stat, Edit, and that brings us to L1 and L2. To clear the list, if you're deleting each list separate, or like each entry separately at this point in the semester, shame on you. Arrow up to L1, press clear, not delete, but clear, and enter, and that clears everything out of the list for you. Okay? So let's actually enter these values. Let's enter vowels in L1. And then because one mistaken data entry could totally change the correlation, I'm going to double check that I've entered all these values correctly, that I didn't miss one. Okay. And then in L2, I'll put the points. And it is very important that when you enter them in, that these need to correspond to each other, because we're looking for the relationship between the variables. So like if you missed an entire entry, you have to make sure that when you re-enter that the values are right next to each other as an ordered pair in the calculator. Okay. And again, I'm just going to double check that I entered everything accurately. You guys should do the same thing. Again, if you enter one number wrong, incorrectly, your whole correlation could be off. So that's step 2. We entered the data into L1 and L2 in the calculator. The next thing we do is we press Stat again. We go over to Calc. And I know we've used one variable stats a lot, but that's not what we're going to use here. We're going to do linear regression, which is number 4. There's actually one on number 8 too, but that's so far away, let's just use 4. So we go to 4. And then as long as our values are in L1 and L2, we can press enter. If you have a new operating system, you might be seeing something a little bit different. It might be asking you, it might show you something like this instead. It might say X list L1, Y list L2. That's great, okay? That's fine if you see that, as long as your X's are in L1 and your Y's are in L2. Then you just arrow down to calculate. You'll just press enter, and you should get the same thing that we do here, okay? So notice it gives us an A and a B value and an R squared value. We do not care about that right now. We will do that in chapter 11. We're going to look at the R value. Traditionally, we round to 2 decimal places, so our R value is going to be about 0.77. So I'll make that note down here that R is about 0.77. And again, there is our R value. Notice it also asks us to interpret that value. So here are the guidelines for interpreting the correlation. Just like we talked about the scatter plots in the last lesson, we want to talk about those three different pieces. First, we want to talk about the strength. So based on the value, we can decide if it's strong, moderate, or weak. We then decide if it's positive or negative. So we talk about the direction. And then we talk about the form. It's always linear when we deal with correlation. That's what correlation does, is it measures the linear association between the two variables. So we always put linear. And then you can use either relationship or association. Do not use the word correlation. If you use correlation to interpret correlation, points will be taken off. You cannot use a word to describe the same word. So we'll talk about the strength, direction, and the form of the relationship between your X, and you'll describe what it is, and your Y, and you'll describe what it is. That means do not use the letters X and Y in your sentence. Talk about what the specific variables are. So let's look at how we would interpret this value that was talking about fouls and points. Again, just use this template. We can say there is a, and let's look, where does 0.77 fall? Well, 0.77 falls here on the moderate part of the spectrum. So for our strength, we will choose moderate. Next, we need to choose the direction. Notice the value of R is positive. That means that the correlation is positive. We used our calculators to calculate R. R always represents a linear relationship. So I will talk about linear. Again, if I'm interpreting correlation, I'm discussing the relationship between variables. So there's a moderate positive linear relationship between, and my X variable was the number of fouls, a player commits, so that's the X, and the Y was the number of points he scores. And I know it's a he because they're talking about the Lakers, okay? I'm not being gender biased here, okay? All right, so that's how you would calculate and interpret R. If you're having issues, there's this great thing called MathLab. Okay? All right, so below are scatter plots using data from 32 NFL teams in the 2008 regular season. Try to match the correlation coefficients with the corresponding scatter plot. Take a minute and see how you guys do there, okay? Go ahead and pause and try to match. So let's see how you guys did. I wouldn't be able to look at this and say, oh, that's R equals this. I think this would be like a matching process of elimination type of a thing. I'm going to look for the strongest relationship I see. Letter C was the strongest one, and I see that that's the strongest, most negative linear relationship that I see. Therefore, I know that letter C would have to be that R equals negative 0.97. The next strongest ones are D and E. They're pretty close, but which one looks stronger? E looks like the strongest positive linear relationship to me. So that means that I would look for the one that was closest to 1. So E would be then 0.89. D then would be the next largest one. R would be 0.82. Next I have A, B, and F. And they're all pretty weak, but of those, I would say that F, I guess, has the most shape to it. And it does look like it's going in a positive direction. And so that's going to be R equals 0.54. Now remember, 0.54 is still pretty darn weak. It's really close to that weak part. So then I have these, oh, let me cross that out. So then I have these guys. They both look pretty random, but notice that we have one that's super close to 0 and one that has a little bit more of a negative pull. Which one really looks like it's being pulled more in a negative direction? To me, letter A looks like it's being more pulled in a negative direction. At one point, like when I was doing this with like Algebra 1 kids, I would take like a thick marker and do this to it, okay? And you can really kind of see that negative relationship. If I tried to do that in letter B, that's really not able to happen. So I'm going to say that A is the one that's more negative, so negative 0.31. And that leaves B to be negative 0.04, which is, again, very close to no association whatsoever. And so that's very appropriate since it's hard to tell if it's increasing or decreasing. It's kind of all over the place, okay? You'll never have to look at a scatter plot and say, this is the R value. It will be one of these situations where you'd match, okay? All right, so let's talk about what association is stronger and why. So based on all 146 Ladies Professional Golf Association golfers in 2009, let's compare the correlation for average driving distance, which is how far the ball travels on a golfer's first swing, and their scoring average, with the correlation for driving accuracy, which is the proportion of drives that land in the fairway, and their scoring average. So distance and scoring average was negative 0.47. Accuracy and scoring average was negative 0.23. Now, remember that since both imply a negative correlation, both are good for golfers because you want a lower score in golf. So which relationship has a stronger association? So the stronger association is going to be the one that is farthest from 0. So that would mean that this guy was. So negative 0.47 is not the relationship. It would be the relationship between driving distance and scoring average. So we can say that average driving distance and scoring average, it's those two numerical variables, has a stronger association since the value of the correlation is farther from 0. So again, the stronger association is going to be the one that is farthest from 0. Also notice that both of these correlations are weak. And that's what you're going to find, you guys, so many times there really just are weak associations. So since both of these correlations are closer to 0 than to negative 1, what can we conclude? All that means is that this means there must be other variables that contribute to a low scoring average. So like driving were the only things they were looking at here. So they were looking at driving distance and driving accuracy. So like maybe, like those of you that are into golf, like maybe something like putting is more important. Maybe if we looked at putting accuracy, that would have a greater impact on the scoring average. So that's the thing, is because these are such weak associations, it probably just means that there are other variables that play into that like a lower scoring average a little more. Okay. So then again, I just want to re-emphasize what we talked about at the previous lesson, that association, and in this case correlation, does not imply cause and effect. The textbook on page 355, if you'd like to read, because I'm sure you read it every night, talks about a Happy Gilmore example. It says that Happy can crush the ball off the tee and drive it farther than all his competitors, but he still finishes last because he can't do anything else won. Okay? What this means is that even though there is a correlation between driving distance and scoring average, there is no guarantee that increasing driving distance will result in lower scores. So again, just because a correlation exists does not mean that one is going to affect the other. Again, the big thing is that correlation does not imply cause and effect. Only tendencies. And to be honest, like even if the association has a correlation of 1, you still can't say cause and effect. So again, if you want more information about that, take a look in the text. Like, they do a pretty nice job discussing it. So that's a little bit about correlation. So I know the other day we were concerned about how we could decide if something was strong, moderate, or weak. Now we can use our calculators to kind of help us out with that. But let's just keep in mind that we cannot conclude any cause and effect from that, okay? All right, thanks so much.